Thank you very much. Hi, everyone. It's a pleasure to be here today. Yeah, I want to talk to you today about what we at S3 call geospatial Gaussian splats. So the fact of creating 3D maps of large environments and to be honest, also of small environments. But I have the feeling that Andre just already gave a perfect introduction of what Gaussian splats are. So actually, he made my job a lot easier. Um, Matt, can you actually play already the first video? Perfect. Yeah, so the first terminology that I want to introduce to you is reality mapping. So reality mapping is what we call the process of creating accurate digital representations of the physical world using images, LiDAR, or both. And I feel like Andre just explained this already really nicely, how you can do this with Gaussian splats. But in fact, the video that you're seeing here in the background is a 3D mesh model that was acquired from a drone in this instance. And I will jump back to my presentation. Um, and yeah, a few words about Esri as a large organization. Esri is a global company with headquarters in Redlands, California, but really it has offices around the world, as you can see in this nice map here, including here in Germany, so in Stuttgart, where I'm at the moment. And what we as Esri build really are geospatial information systems. So in short, we call it GIS. And here's just a bit of an overview of things that GIS enables our users to do. So the core idea is that a GIS is used to integrate all types of data via their location in a defined coordinate system usually. So, and this in turn enables users to create maps of layered information to measure and manage data on, run complex analysis, run simulations, plan and design, and ultimately really make decisions and take action in the real world. The platform that we as Esri built specifically is called ArcGIS. And ArcGIS is a comprehensive geospatial platform, and we describe it this way because our users create their systems and solutions on top of that platform. So it's actually an extendable platform for our users. ArcGIS Pro Enterprise and Online are some of the foundational products that deliver the capabilities of the platform, like mapping, 3D imagery, analytics, data management, much more. And ArcGIS is also available in different flavors as software as a service or platform as a service that you can just start using right away. And while ArcGIS is designed as this horizontal platform with generic tools, it also supports businesses and mission-focused systems and also targeted applications. And I will talk about some of those in a sec. But before jumping into that, I just want to show you like really briefly a couple of use cases, just so you get a feeling what we're doing. So one big application of GIS is urban planning and the evolution of cities, infrastructure development, including planning of renewable energy and natural resource management, engineering and construction, including often asset management use cases, which is also a really interesting one for Gaussian Splat. So really tracking where assets are, for example, in a city and their condition. Disaster response, for example, after an incident occurred. The LA wildfires are an example for that happened in the last years. And I could keep going on, but we'll stop here because I really just want to give you a small glimpse of what ArcGIS is used for. And traditionally, a lot of this work that I just described was done in 2D. So classic 2D maps as you know them. But meanwhile, a lot of the work is done in 3D. So we're really fully transitioning into connected digital twins, which is also one of the big drivers of our work here in Stuttgart. And a digital twin can really be created from anything. So it can be a single site, as you see on the top. It can be a construction site, but it can also expand to cities, provinces, or entire regions or countries. And I don't want to go into too much detail here, but I think it's worth briefly showing this maturity curve because there's a lot of varied understanding of what a digital twin is. And I think this maturity curve actually nicely shows why that is. So in fact, there really are these different levels of maturities to a digital twin. So at the very bottom, you'd see that in its most basic form, a digital twin is just descriptive, which means it describes the real world at a given time. It's static, and techniques like reality mapping, for example, are used to create it. But of course, it's not where the idea of the digital twin ends. The idea is really to move up on this maturity curve. So they are meant to connect live data, for example, from IoT sensors, be predictive, enable forecasting and simulations, which then in turn allows for modeling various scenarios like a potential flooding, and ultimately become really autonomous systems that are updated automatically and do predictive work as well. And I'm showing this because it actually shows nicely that reality mapping is really kind of a core pillar in this, and will also help frame why Gaussian splats are so interesting for this evolution. And here I would ask Matt to play the second video. Yeah, so what you can actually see here, just to give you an impression of what a digital twin of a city can look like. So this is actually the city of Oslo in Norway. And this is using, for example, a wind simulation in ArcGIS to show how these models can be used actually for decision making. And there's all sorts of visualization that we do in ArcGIS. So really reality mapping products are by far not the only one. There's also a lot of other data like BIM data, imagery, point clouds, voxel layers, and so on and so forth that are supported. And really the power comes in when all of these different layer types are actually layered on top of each other, and people can start measuring in them and deriving information. And here's actually another good example from a large and disastrous flooding that we had in Ahrtal in Germany. That actually triggered a statewide digital twin initiative for disaster response. So actually today, the whole state of North Rhine-Westphalia in Germany is covered every 2 years at a 10 centimeter resolution from crewed aircrafts. And the state creates a 3D mesh model out of that and makes it available as open data. So you can actually publicly view it. And the area covered is about 34,000 square kilometers or 13,000 square miles, just to give you an impression of the size of this data. Perfect. So what you're actually seeing here is a very famous construction site in Germany, at least in Stuttgart, right next door to where I'm sitting, in fact. And this is actually our train station, so the train station of the city. And the city decided some time ago to move the entire train station underground. So actually a really multi-billion-dollar project. This has already been in construction for about 15 years. And here you can actually see the fidelity of Gaussian splats. So what was captured here was from drone imagery. What I showed you before of Oslo was from imagery from a crewed aircraft. And this here is really drone images. And this imagery is then kind of processed through our reality mapping pipeline fully automatically, and generating these type of results with this type of fidelity. And I think we can actually already start switching back Matt. And when I talk about reality mapping in general at Esri, then as I already outlined a bit, what we really focus on are exactly these various scales of data. So on the one hand side, really satellite imagery, which gives us global coverage, then crewed aircraft. So these are really manned aircraft with really large frame cameras mounted on them. So just to give you a feeling, some of these cameras capture between 300 megapixels and 450 megapixels per image. And they often capture multiple images at the same time, and you quickly go into the area of thousands or tens of thousands or even hundreds of thousands of them that need to be processed, so really terabytes of data. And when we go down to the site level, we usually have drone captures, but more recently also drones are advancing really quickly. So we are also starting to see really citywide, city scale capture also from drones. And yeah, I don't want to bore you too much with the details, but I think it's interesting for you to have kind of a feeling. Actually, when we talk about reality mapping, we have a reality mapping suite, in fact. So SiteScan is a software as a SaaS software as a service product that is focused on drone mapping. And if you've never done anything with it, that's maybe your easiest entry point. But then we also have more focused apps for really professional use. SiteScan is also for professional use. But for more focused desktop apps, Drone to Map, Reality Studio, and Reality for ArcGIS Pro. And especially Reality Studio is really targeted at these citywide, countrywide use cases in reality for ArcGIS Pro, more for people that are used to working in ArcGIS Pro, which is our flagship product at Esri, and yeah, enables them to do reality mapping right inside the product. But now I want to get to Gaussian splats and what Gaussian splats really are from our perspective. I think Andre already perfectly described them, but I want to give you a bit of a different look at it. What it really is for us is a new, highly realistic layer that we add to this GIS that I introduced in the beginning. So you can really best compare them to a point cloud or a 3D mesh model consisting of triangles, just that they instead consist of these small, colored, semi-transparent Gaussian blobs, right? And what makes them so interesting is that they not only offer a way to represent 3D scenes, but also come with an algorithm for how this representation can be created from a set of overlapping images. So from this perspective, they really solve a similar problem as traditional photogrammetry. It's just that they do it in a different way, in a distinctly new way. And this leads also to a different scene representation at the end of the day. Yeah, and I don't want to go into too much detail because I think it was already covered quite nicely. But if you want to have like a mental model of it, basically how it looks like. So basically all that Gaussian splats are is basically they are a position, XYZ, an orientation and a scale. And by that describe an ellipsoid in space, so similar to what you see on the top right, but they also have an opacity and can have few dependent colors. And how this kind of works is that you, if you look at this diagram at the bottom, is that you need some sort of initialization. You need to create initialization, but then you're actually starting to kind of run this optimization loop, basically, where all of these parameters that I just mentioned, so position, orientation, scale, and so on, they are optimized. And every time this splats are kind of rendered and compared to the actual input images. So it's actually an optimization running against the input images that you provide, and it's trying to make it look as similar as possible. So it's a pretty simple approach, but a really smart approach as well, because it leads to these really nice results. And to give you a bit of a feeling for what they're good at, so one of the things that they are really good at, and this was shown perfectly before, is for modeling vegetation, which is traditionally very hard to do for 3D meshes, for example, because you actually need to have a lot of triangles to model them well. Also, they're moving and a lot of other things. So especially in our use cases, right, where capture data is captured once, and then we need to make the best out of the data that the user has. This is actually a great property to have. Secondly, they're capable of displaying reflections and also handling transparent surface as well, which is of course possible on meshes, but really hard to achieve from photogrammetry, at least in outdoor conditions with changing lighting and all of these things. And lastly, what is really important for us actually is that they are really good at representing thin and complex structures and also at reconstructing them. Because again, this is really hard for meshes to do. And I can show you some examples of that in a second. But the reason that it's so hard for meshes is that they actually need to always somehow span some sort of volume, basically. So you actually need to observe the object from all sides, and you need to be able to, even for thin objects, really create a volume of triangles, which is really hard to do automatically. And with that, Matt, could you play the next video that will actually give you a bit of a feeling for some results that we produced today from Truong Gaussian splats. Yeah, exactly. So these are some examples of Gaussian splats, again created automatically from drone imagery. And you can really see the detail, what they're good at. And maybe also to point out a thing that Gaussian splats are inherently maybe not so good at as a mesh is really that in Gaussian splats, you tie the texture resolution to the geometry, basically, because you only have these colored blobs, right, opaque blobs. So what's possible on a mesh is if you have a plane, you can just have two triangles basically, but still apply whatever texture resolution you want on top of it. That is quite hard for Gaussian splats to do. So if you have a high frequency, low geometric complexity surface, you actually still need a lot of Gaussian splats just because of the texture. But if you look at these thin details, I think this on the other hand side really what yeah, enables entirely new use cases that were hard to capture from 3D mesh models automatically. And I think with that we can also jump back again. And here's some more impressions, so you get a feeling what are the data we actually capture. So for example, not we capture, but our users capture and produce. So this here is, again, the city of Stuttgart, the actual part of the train station that's going underground, and this time captured from an airplane. So at an altitude of about 1,000 meters. And what you can actually see is that these Gaussian splats are still at this relatively low resolution in comparison, able to represent thin structures like these power lines. And here's a bit of a zoomed out view on that. And here are some examples from our automated pipeline that clearly show you the benefits of Gaussian splats. So on the left-hand side, you see a 3D mesh as produced by us automatically. And on the right-hand side, you see a Gaussian splat. And if you look at these railings, for example, you clearly see the areas where Gaussian splats shine. And I have some more examples of that. So again, this is power lines over train stations, really hard for 3D meshes to capture well. Or here, these thin details. Here you have a glass building, which is also inherently challenging for meshes. And with that, I think we can play the last video, Matt. This is actually just another capture of a building, and actually what you're seeing is here really how we're navigating live in this scene basically. So this is ArcGIS Pro, one of Esri's products, and we're just navigating around it live. And the interesting piece, I'm also going to talk about this a bit more in more detail later, is that actually what's going on here is in order to display these Gaussian splats efficiently is that there is actually a whole level of detail structure behind them. So this is already baked into the results automatically that we produce, and it's doing this LOD switching to be able to handle these large scenes. So again, this is a drone capture, so just one building, but already this one building is yeah, quickly exceeding what you would be able to render if you had to keep all of the Gaussians in memory. Okay, so now I want to talk a bit more about what like the special expectations are that really our users also have when we talk about Gaussian splats, and why we also talk about geospatial Gaussian splats. So one of the biggest needs that our users have is that Gaussian splats are geo-referenced, and what we mean by that is that they are accurately located in any type of defined coordinate system, so that when I click at a point, I actually get back a real point in a real coordinate system, basically, and I can identify where that point is. They need to be scalable, so this speaks to the LOD structure that I just showed. They need to be streamable, so that's a really strong requirement. Most of our GIS, or a lot of GIS work today, is done online, which means people are hosting their data online, gigabytes and terabytes of meshes and Gaussian splats, and they actually want to stream it to their browser, so it actually needs to render in browser. Then standardization, I will talk a bit more about that later, but this is, of course, I mean, with the whole digital twin pitch that I gave in the beginning, it's extremely important, right, that we can actually ingest data from different systems, but we can also produce data that can be ingested by other systems. And they need to be trustworthy and measurable. And that's actually an interesting point, because really what our users ultimately want to do is, once they have positioned these Gaussian splats somewhere in their map, is they want to measure in them, right? They want to find out how high things are. They want to visually inspect them. And some of the challenges that we're facing with that, with the traditional Gaussian splatting approach, really is that they produce inaccuracies, especially if you have suboptimal capture, which you basically have all the time. So they will have show floaters, and there's also a distinct shrinking bias in the Gaussian splatting approach. So in the public one that's used, and really what we've been working on a lot in the past year or more than a year is really yeah, to use our know-how in photogrammetry, because really it still applies to accurately georeference, but also introduce more knowledge about 3D scenes into the Gaussian splat approach to make sure that we avoid this shrinking bias. And you can see this a bit shown on the right here. So basically the default Gaussian splat approach actually shrinks data a bit, which makes it look quite pleasant, but can actually cause a shrinkage of up to 2 times the image resolution. So actually you can be off by centimeters when you measure in them. And yeah, so we really work towards eliminating this shrinking bias. Um, and yeah, here's some more results of that, just to give you a feeling. And now speaking a bit more to the LOD structure that I also mentioned before. So as I said, really Gaussian splats for us, they're just another layer type, right? They're not replacing 3D meshes or replacing point clouds. There's still value in these. It's just that for certain use cases, they are the best tool in your toolbox, basically. And what we need to ensure for all of these data types is basically that we can stream them efficiently. Um, so actually there's multiple formats, right, that our users use to do this. And I just want to point out two, because they might not be as known in this round, but they are basically the go-to formats for both meshes and Gaussian splats when it comes to managing this vast amount of data. And this is on the one hand side I3S, and on the other hand 3D tiles. So both of them are OGC standard formats. So you can look up the spec online, and a lot of tools can read and write them. And what they're actually doing is that they have this built-in level of detail structure. So actually they store really the mesh at different resolutions with also defined switching logic when to switch between those resolutions. And similarly, the same happens for Gaussian splat. And in fact, one of the things that we've also been working on in the past month, and we are also happy that we could announce, basically, is that together with Kronos and OGC, we actually were able to expand the GLTF asset standard to connect or to add Gaussian splats support, basically. And this was done with actually a variety of different companies. So Niantic, Bentley, and others were involved there as well. Um, and yeah, so this is what we use today. In fact, we're writing directly to the standard, which also enables everybody else to write Gaussian splats in a way or convert them to 3D tiles and ingest that into ArcGIS, or vice versa, use our Gaussian splats that we produce out of reality mapping in other systems. All right, some more, I'm coming to the end of my presentation, some more interesting road ahead items that I can share. So I already showed this, right? Our focus is really around crewed aircrafts, drones, and satellite imagery and LiDAR today, but actually what we're looking at the moment is really to expand more into mobile mapping, so going more into ground level reconstructions, and then eventually also to more sensors. So the video here is more a placeholder for other sensors that are out there, because this is really something that we see in applications quite a lot. So cities are capturing their streets with mobile mapping systems from a car, for example. And yeah, want to similarly to the other data, use this or produce Gaussian splats and meshes from this data, and then use it in their GIS. They can already today, of course, insert the point clouds from the laser scans or the imagery. But really, the novelty would be producing derived products from them, and and then using these derived products in further workflows. And here's a small video that shows one street actually that was captured from a mobile mapping system, and how this can look like in a Gaussian splat, basically. So that's some of the work that's currently in progress that we're working on, and again, this will be yet another exciting challenge, because this data is also really growing big in data amounts very quickly. So we talk here about hundreds of thousands of images just for 2-3 square kilometers of a city. So if you imagine doing this for a couple hundred square kilometers, you will quickly end up in the millions of images, basically. Yes. And with that, I actually already come to my closing. So on the one hand side, I just want to share, we do offer academic licenses also for educational purposes. So if you want to learn more about that, I added a link here. This will actually, guide you through the process, basically. So you will find out, depending on the country that you live in, whom to reach out to. And then, of course, also we as Esri, we are hiring, and especially also in Stuttgart. So you get a nice view here of our team here in Stuttgart. We really do hire for everything that I presented. There's a QR code here on the slide. It's also the link. You can scan it if you're interested. Also, if you're interested in internship opportunities, I think they're not currently officially listed, but we are quite interested in interns as well. And of course, this brings you to the Esri careers page, so you will see our R&D center roles first, but you can also actually scan through all the positions that are open internationally. So there's actually quite a lot of cool places that Esri is at, both in here in Europe, but also in the US, also in Asian Pacifics, and so on and so forth. So yeah, check it out. And yeah, with that, actually, I can only say thank you. Thank you also, Matt, for organizing this event, and maybe also some last personal words before I close. I actually forgot to mention that in the beginning. So I actually made myself the switch from VFX, so visual effects, to GIS a couple of years ago. Previously worked at the moving picture company in London at MPC in software development for rendering. So worked a lot with RenderMan. And what I can recommend if you want to learn more about GIS, if that was in any way interesting to you, then really watch out for things like computer vision, photogrammetry, remote sensing, surveying. But also if you already have a background in any of them, it's certainly a really interesting space to be in. I personally came to love it myself. It's really an exciting field with really real world impact, and there's really also a lot of interesting things too. So if you think you know a lot about meshes and point clouds and whatever and what they're used for, there's actually a whole nother space to explore for you when it comes to coordinate system, large data, high performance computing, and many more things. So yeah, can certainly recommend it. And with that, I would close.
All right. Let me quickly see if I can appear again. Where is my webcam? Tobias, just join me again. Let's do a quick Q&A.
Sure.
All right. Yeah. Perfect. Yeah. So thanks a lot for the presentation. Really fantastic overview of the technology, and and the kind of also these real world applications of mapping and measuring and all of those aspects. And I mean, I'm so happy to see this with the first presentation. We were in a completely different industry, right? Kind of the creative industries, entertainment, rendering for commercials, for historic projects, and so on. And now we're suddenly in GIS and remote sensing, and we are talking about all of those different aspects. And this is why I'm so happy that kind of this bridging idea of the ICE.ART conference, where we talk about 3D environments, independent or agnostic of the industry. This actually works so well. And I mean, even you personally, it's really cool. You worked in visual effects before, and now you jumped over to this industry, like literally proving that it's possible to switch careers, to also not be afraid of searching in other careers, which may be a bit more technical, a bit more creative, whatever. But I'm really happy to see that that this is, we can talk about these things, and we are very deliberately also kind of mixing and matching presentations from multiple industries, right? So there's I noted a bunch of questions down. We probably won't have the time for everything, but so there's a few comments and questions probably from the audience. So let's dive into those first. So Bella is writing. Hi, Tobias. Thanks for the overview. Two quick questions. Something like a block of houses or an industrial site. How long does the algorithm take to create the splat itself? So that's the first question.
I can go on that already. It's actually very hard to answer because it really depends on a huge amount of factors, actually, like with which density this data was captured, the resolution it was captured at. So yeah, it really depends vastly. But if we're now talking about like a drone capture, let's say, of if you have like a couple of blocks, maybe you end up in the 1,000, 2,000 images of, I don't know, 25 megapixels, something, 24 in that ballpark, then I would say a couple of hours to create it automatically. So put the images in, run 4 or 5 hours, and then you have the results. If you're talking about really city scale data, so where we quickly have, I mean, some of our customers have produced data sets of 50 terabytes of input images, then you really talk about weeks and months of processing. And actually for that, I didn't touch on this at all, but like a huge part of what we do actually is really this more high performance computing aspect. So really where you connect actually a large number of machines together to process the data. So either on site or also in the cloud. Yeah, so I think this gives like a bit of a feeling. Yeah.
Is that, if I can just add a question on with that. So I mean, Esri, you guys are known for having, with ArcGIS, you guys have a platform. You mentioned the tools, but you also mentioned also kind of the standalone tools for processing, for example, the splats. But just because people may be curious, like Bela, are you guys providing tools just for, let's say, local processing, or would it also be possible, or does it potentially also exist, where you have basically, let's say, crunching compute as part of a, let's say, subscription or cloud points or something like that, where a company, for example, that doesn't have the hardware or the GPUs or the processing power, and doesn't have the knowledge of, let's say, renting cloud compute and install everything, so they can just upload all like the images with their parameter and lens information or whatever, and just get the splats back. Does this also exist?
Yes, absolutely. So this is basically side scan. I briefly talked about it in the beginning.
Mm-hmm.
So SideScan as a product is software as a service. So exactly as you described it, you upload your images, they are processed on Esri infrastructure in the cloud, and you get the results back. You can even view them in your browser or download them. And even connected to that, I didn't talk about that, but maybe also interesting is there's also a flight app by Esri. It's called ArcGIS Flight, which actually enables you to plan your drone flight. So what Andre also showed you, plan your drone flight for certain use cases, and then automatically also upload the data to SideScan, process it, get the results. So that would be the easiest entry point, and that works, based on credits. So you pay just for the data that you process, whereas the desktop products are more license based. But yeah.
Right. I mean, this by itself could be really cool for, I don't know, for companies that work in film, and they need to scan 3D sets, like physical 3D sets, but they wouldn't know how to do that. So there's a use case for that using GIS technology. I mean, it's perfect, right? Yeah, and how would they know if they didn't hear it from you in this presentation today, right? Cool, but let's go back to Bella's second question. So also, and that is he writes it's Stuttgart specific. Will those tools be consumer available before Stuttgart Bahnhof is finished? What is your expectation when this will be a mature technology, or when can an idiot like myself do that with my flat, so with where he lives?
Um, Actually, I mean, Gaussian splats themselves, I would say they are pretty mature in the sense of that there's tons of apps out there. I don't know, you can just download for free on your phone and literally take images of your living room, and they work. I mean, they do produce quite good results for um, like the amount of effort that you put in. And then there's of course the whole more like professional side is more where we are at, where it's really, as I tried to outline like this geospatial use case, where it's really about locating this data also accurately. So there comes a lot more with it on top, so that would go beyond scanning your living room. Um, but I would say the technique is quite mature. It produces really good results from um, a lot of data if you capture properly. I think where the systems are still evolving is on the tools that you have after you created the Gaussian splats, basically. So we're still in a phase where many companies are making the switch to at all supporting them. I mean, you heard it, Octane is supporting it. I don't know which other renderers are supporting it. It's still in that adoption phase, let's say. And then also a lot of the analysis tools on top of them, or editing them, relighting, like everything that comes after you produce them. I think this is where actually more the downstream technologies maybe still needs to evolve and adopt more than the technique is lacking, if that makes sense.
Yeah. So for a person that just let's say as a hobby wants to get into creating these splats or just starting to experiment, what's approximately the price point of let's say, for example, a drone or a camera, and which kind of drone or type of camera would you recommend as a starting point for a hobbyist, just approximately?
Yeah, of course, I don't want to make any commercial for a specific vendor here, but I mean, like what I can point out, maybe like the private Toby speaking is that there is, I mean, the DJI drones are by far the cheapest that you can get, I think, for the value that they deliver, as far as I know. Of course, there's also a whole topic about DJI being a Chinese company. So if you're in the US, you may not be allowed to fly that anymore. So there's also some considerations coming with that. But in Europe, they're still very much around, in Asia, of course, as well. Um, and yeah, I mean, some of my friends, of course, do that as well in their free time, and you can get a okay drone for like €1,000 in Germany.
So
Probably
it's
even cheaper in
about
some other places.
$1,000 US dollars
Yes,
approximately. Yeah, yeah, yeah.
yes, and then you put a proper camera on it, like whatever, with 20 megapixels or above. You watch some videos about how to set it up. So maybe no automatic lighting and stuff like that. But yeah, and then off you go. Like the entry hurdle is relatively low. I think flying this and doing this is a learning curve for sure. So I wouldn't say it's you just do it for the first time and it's perfect. But as I said, there are these flight apps out there like ArcGIS Flight, which I can recommend that you can get, and they enable you to do actually the flight planning and then also autonomously actually move the drone during the flight and capture the data. So actually, it's really getting quite simple.
Cool. So there's another question which Mike posted. What is currently the biggest obstacle in advancing the technology to stream higher and higher fidelity scans? Is it know-how, or is it hardware, or is it software?
So it's really about streaming the data.
Yeah.
Did I get it right? Okay.
Yeah.
I would say the obstacles are really mostly overcome, in my opinion. So if you have meanwhile a good enough laptop, then I mean you can stream it basically and it works. So even these citywide Gaussian splats or citywide meshes, I mean really the precondition is this LOD structure that I talked about. So this level of details that are encoded in the data, and that is actually something that we spent a lot of engineering effort on to get right, both on the creation side, so when we create these Gaussian splats and add this level of detail structure in, but also on the consumption side. So when, for example, our products like ArcGIS Online read this data from somewhere and display it. But there are good solutions out there. I think they're not as widely spread yet. Esri, of course, I think for us that's our bread and butter, large data. That's what needs to work. So that's why we really put a lot of effort into that early on. And there's similar approaches by others, like I don't know if you've heard about Cesium or Bentley. So they're doing similar things. And yeah, I would say this is really already in a good state. So if I would have to pick one of those, I would say software, because I think it's not widely as widely spread yet, let's say. But even there, maybe one other thing to mention is like there's also SDKs meanwhile for game engines, for example, like Unreal or Unity, that would actually allow you to stream also GIS data into your game engine, for example, and use it in there, and it actually does on the fly certain things. So like GIS data is usually as I said, in some sort of global coordinates. So these are big numbers basically that are that cannot be represented with floating points. So usually they don't work out of the box in a game engine. So there actually needs to be some translation being done on the fly and things like that. But yeah, you can actually stream in this data into your game engine actually through these SDKs. So yeah, I would say the hurdles are really shrinking.
But so in this case for the shrinking, I mean, you just mentioned that the LOD system is kind of a prerequisite. Is that something that is proprietary Esri tech, or would that be part of the, let's say, the OGC, let's say I3S standard that kind of comes with the data format, and the tools need to just crunch the data into those LODs beforehand, so that companies that don't have the tools, because that's, you mentioned it's really hard to implement that, which would be a software problem.
Mm-hmm. Yeah. So this is basically what these standards are for. So they define this level of detail structure, how to write it into that. There's also there's actually multiple tools. So basically, any company can now implement an export to these formats, right? So it's a well-defined format. The only challenges that it has, of course, is creating actually downsampling geometry or texture in a way that it looks pleasant. It's actually harder than one might think. And so that's the part that is, let's say, proprietary. But also there now that for the whole format and so on is standardized, we're also working more and more that people can bring, for example, their PLY file without level of detail structure, and it gets converted, and then they can use it in our system, but also outside, and things like that are happening. Yeah.
Very cool, very cool. So I just have one last question from my side, and then I think we'll move on to a quick break. So maybe, and I'm not sure if this really kind of makes sense in this context, but so I was inspired by the first presentation of Andre. He showed the same tree in two different seasons because he saved the flight path. And so it's basically because it's exactly the same flight path, and obviously ignoring that the tree may have grown slightly and so on. But the thought behind that just brought me, or is kind of making the link now to GIS data. So my question would be, with, you mentioned that the Splats, basically there's a point, then it had the point basically as a scale. It's a kind of this elliptic form. It has opacity, and then it has like basically the, what's it called, like the spherical harmonics, which is basically the color based on the viewing direction, right? Which captures exactly the reflections and all of that stuff. So are there efforts, or is that already solved, to, for example, fly the drone again multiple times during, for example, day and night, or even more times, 2, 3, 4 times a day, but then actually based on the delta of the color information, be able to remove the lighting, kind of delighting the scene so that you have more like an albedo representation. And I don't know, potentially based on how that delta is computed, even going into, I don't know, predicting some sort of the BRDF function to be able to derive which material it could be for classification and so on. Is that so? So basically, that would be, first of all, processing, but also other types of attribution per splat. That could be like ultraviolet information or other physical properties of the surface. Is that something that is realistic, or is pursued, or is that in the future?
I haven't seen anywhere the approach that you're talking about. So basically, with the idea of flying the same object multiple times under different lighting conditions.
I'm gonna patent it right now.
No, I haven't seen that being done. But what, of course, we do see a lot is what you touched on is very relevant, right? Knowing what type of material something is made out of to track. I don't know, if you think about time-enabled capture, so you capture the same construction site multiple times of the day, right?
Yeah.
You might want to know, okay, here I don't know, before I had this volume of Earth and now it's over there. But for that, I want to somehow be able to figure out what type of um, uh, material that is, right? So I can make the connection again later
Yeah.
and things like that. So and so this sort of stuff, of course, is something that we're working on also with like various, or Esri is working on with like various um, deep learning models that you can apply on top of the data and so on, but not based on like a derived BRDF before. So that's not a path that we've been pursuing. I
Not
mean, I know,
yet.
of course, that a lot of yeah, exactly. Now that you said it, no, I'm kidding. Yeah, I think I'm not sure if this would be the approach to go for, to be entirely honest, because the flying is also high effort, and you still need to know where. I mean, you can probably, based on day and time of year and so on, derive where the sun roughly must be and things like that, right?
Like, yeah,
Um,
yeah, yeah.
but yeah, you need to figure out quite some things to do it. And yeah, I know, of course, that this is being done under controlled lighting environments, right? Where you take multiple images with like various lighting in like a studio or something, and then you do exactly what you described. But I haven't seen that being done. Maybe
Yeah,
somebody else, but I
yeah,
don't know
yeah,
of it.
yeah, yeah. Very cool. I mean, I got a ton more points here, and but I think this has been fantastic, really cool. So we already made this massive jump from entertainment applications to using basically exactly the same. It's just colored points, right? Completely jumping into the world of GIS or 3D GIS. So this has been fantastic. So I'll just or I would say we're just going to do a quick break, a couple minutes. I'll just play a video, like 7 minutes or so, something like that, and then we'll be back and jump into something that is completely different. We'll hear about business from Andre Thomas. So thanks, Toby, for being here. It's been a pleasure, and we'll see you again afterwards. All right.
Thank you as
Enjoy
well.
the break.